Okay, let's get started, everyone. My name's Alan Haupt with CA Technologies, and welcome to today's webcast titled Tips and Tricks for Building Your CA Service Management Solution on Amazon Web Service. And this will be a hands-on lab demonstration. Before I introduce our speaker, I have just a couple things to go through logistically. First off, we'll be doing a live Q&A in today's session, as well as a Q&A through the Q&A tab or button icon that is on your screen. If you're going to do a live Q&A, you are welcome to interrupt our speaker. Your lines are muted to start, so you'll have to hit #6 to unmute your line, and then *6 to remute your line. If you prefer to use the Q&A tab to enter your questions, you can do that. Just make sure you address the question to all participants, and we'll answer those questions as the session is going on. So for today's session, I'm going to introduce Brian Poissant. Brian is Vice President of Engineering Services at CA Technologies. He has extensive experience in service management, Amazon Web Services, and Brian, I'm going to let you explain all those acronyms that you have after your name for your Amazon Web Service experience. So Brian, take it away.
It's just me practicing my alphabet, usually. Let's see if I can get on to the next. There we go, lots of this. So, as Alan mentioned, I work with the CA SWAT team, and I have for years, and have almost 20 years now on service management as a whole. But what I started doing about 10 years ago is working with Amazon Web Services. Had originally looked at it for a customer and kind of just fell in love with it. So I am a triple certified at this point, Amazon architect, sysops, and developer. And I've been working a lot with the ITSM products to get them deployable and scalable and CI/CD automated out on Amazon over the past few years. And what I wanted to do today is share some of my experiences and some of my design thoughts in how we've been able to help customers put these solutions out on Amazon. And it is Amazon. I will say it is Amazon specific, but most of the thought processes and practices can be employed whether you're using Amazon or Azure or Google Cloud, your choice, in many cases VMware. So just go over what we're going to talk about today. Is going to be a primer on Amazon. I can't really talk about Amazon and our products without everyone being at least level set on how Amazon works and what Amazon is and why it's advantageous to get these products out onto the cloud for your own implementations. Additionally, we're going to look over some of the code that I use to automate that. We're going to look at some of the network architectures and challenges that I've had over the years in networking the solutions. As you all know, ITSM is fairly, how can we say, experienced architecture. So it's had its ups and downs over the years, but it was never meant to be built out on the cloud. It's not cloud native, as we say. So taking these applications, and again, whether it's ITSM or any other monolithic implementation of a software architecture and moving it to the cloud takes a lot of thought and some good best practices. So we'll look at some of those and then finally look at some of the next steps that you can go into and maybe practice or implement in your own environments. So why Amazon? Why automate? Why is anyone looking at cloud? I don't think I really need to go into this too much, but the initial purpose was for cost savings. There was that trade-off of capital expenditures for operational expenditures that in different countries had a lot of good taxation benefits as well as budgeting benefits. You could also kind of think about things as an endless bowl of fun. I mean, you've got compute capabilities, you've got storage capabilities, you've got networking capabilities available to you that are almost unlimited. I won't say it is unlimited. Obviously, everything has limitations. But for most people's implementations, it's got more than you will ever need. there are some words that get thrown around pretty easily, and I wanted to just clear the air right up front as to what we're talking about here. Infrastructure as a service, platform as a service, software as a service. These are the definitions that I work from. If people need to segment these things into separate silos, this is where they get segmented. I tend to not focus too much on the official things. I tend to look at what is the customer's problem, what's their challenge, what do we need to address, and then just kind of go at it. But some people will come in and say, look, we've looked at our IaaS solution and it's going to be Amazon, but we're running, you know, OpenShift as a platform. So can we do that on Amazon? And of course the answer is yes. And, oh, that was a nice transition. And in case anyone's wondering, this was actually a presentation I had written, what, Alan, about 9 months ago or so for CA World, and unfortunately I was unable to attend CA World. So if you see CA World all over the place, that's why. I just never had a chance to present, and happily, Alan has given us an opportunity to do that. Deployment models. You can deploy in the cloud entirely. Deploy your software solutions, whether it's service management, whether it's catalog, PAM, any of the tools that we are generally aware of. They can all be deployed entirely on cloud. But many people are driven by governance limitations, especially with the oncoming and arrival of GDPR. So we are going to have to understand that when you're deploying these things going forward, if you do not have an Amazon bunker in your country, chances are you will have to keep your data inside your brick and mortar, inside your own facilities. And that's okay. I mean, again, these are all networking challenges that Amazon has addressed over the years, and it works quite well. It was actually one of the first deployments I did was to build dual VPN connections between CA and Amazon, and to ensure that our data and data sets stayed inside of CA's brick and mortar. Amazon also supports a long list now of compliance, and these are available on the Amazon website. I did not put up GDPR because at the time of the writing, it wasn't clear that they had cleared it, but they have, and did so in time before the May, I think, 18th deadline, or May 25th deadline. And then what can we do? These are products that that are most popular on Amazon for us. In other words, I've made all of these work so that they could be either offered to customers that are logging in to these products from the internet, from the open internet in a secure fashion, or have deployed these in hybrid fashions where the data set is behind the brick and mortar and we put a tunnel in place to connect to that data set. And as you can see, this is basically R17 at its roots. So when you're deploying the ITSM solution, we have lots of services. You can see at the bottom there's collaboration services, there's search services, there's unified self-service. All of these can be microserviced. I don't know which ones are or aren't at this point because, quite honestly, I didn't need, for our purposes, to go into the containerization of every microservice, specifically with Service Desk. Would it be a good idea? Probably eventually, and I know that we're moving in that direction with Xflow and unified self-service and whatnot, but ultimately, because we have the resources available to us on Amazon, we're not really limited to size. So we don't need to do it necessarily from a performance perspective. What we look at first is generally DRP and security. So whenever I'm designing an architecture for an Amazon deployment, I go at it with a security-first mentality. When you compare the different ways that you design, on Amazon, you're always going to be able to scale. You can scale both directions horizontally and add servers and servers, or you can scale vertically and just add CPU or compute or add memory or add storage and whatnot, or add bandwidth. Static on-prem architectures must be built to worst-case scenarios. For those of you who, you're probably deploying in VMware now if you're on site, you're not dedicating full-blown hardware to service desk. You always, when you're designing your implementation, you're designing for the worst-case scenario. What happens if, there's an earthquake? What happens if there's a network outage and we get hit with 100 requests every 3 seconds? That can be very expensive, as many of you have probably found out. Do you need to have DRP versus fault tolerance? There's a big difference in that respect, too, in regards to how you architect the solution when you're doing your standard monolithic architecture deployments. AWS kind of avoids a lot of that. You don't have to work towards the worst-case scenario. What you aim for is the general case scenario, and then you plan for scaling up, scaling out, when you have those worst-case scenarios come into play. The other nice thing about Amazon is that it has bunkers in most of the GDPR country areas that it needs at this point. I got it later on in the slide set, but I know that they keep expanding and keep expanding. So when we're talking about Amazon versus our own monolithic architectures, I kind of like to compare pets and cattle. When it's my architecture inside my company's building, servers have names. I give them names, I patch them, I'm, making sure they're running okay and making sure that they have, the latest and greatest stuff on them. In Amazon, I don't really care. I don't really go and fix something. I kind of just go and say, I've got 40 servers running in this cluster, and if one dies, great, something else comes up and takes care of it. I'm not really in love with each one of my own servers. So that adds another dimension to designing an architecture for ITSM on Amazon. You want to make sure that you're not really paying too much attention to each individual server. I've had people come in and say, look, I need to be able to RDP to every one of my servers, and that generally indicates that there's an opportunity for automation. If you're caring too much about a server and spending too much time with it, that's where your automation needs to start kicking in and saying, okay, well, it's sick, how can I automatically replace it? And that's where the cloud really starts shining, because you start building your infrastructure as code instead of just, hey, I've got to go build this box and deploy it and then manage it and patch it and make sure it's running and monitor it. Not really the way we go about things when we're architecting for the cloud. I'll pause for a minute. Any questions, or Brian, what are you thinking, or stuff like that? Cool. So key takeaways. You want to look at building service management in a secure fashion. Obviously, you're out on a public cloud. Obviously, you want to make sure that at every opportunity, you are locking things down. You're ensuring your data is transferred in encrypted formats and that it's stored in encrypted formats. But the reality is, you still have physical security to be concerned about. Who has access to these boxes? Where are they? What specifically are they next to? Are you sharing data in a slice on a database? A lot of companies have these very, very valid concerns. So Amazon employs what they call a shared security model. They will secure the physical layer, and they secure pretty much everything up to the OS, after which we are required to secure everything after that. It's actually a pretty good deal, because I mean, it's nice that I don't, when I remember the old days when I'd have to go and build a server and make sure it's in a locked room and make sure that the air conditioning is running and all of that. I don't have to worry about any of the physical stuff anymore, and that's what I mean by physical stuff. I do have to make sure things are patched. I do have to make sure that my security and network design is, 110% locked down. But that can also all be automated. And we're going to see how we do that going forward here. We're also wanting to design expecting failures. If you design for failure up front, you will likely not have as much of an exposure or a risk surface, if you will, if a failure does occur. Failures occur, no question about it. They have failed drives. I've had failed drives on Amazon. I've had S3s not, buckets not available, et cetera. But at the end of the day, a lot of these failures can be fixed automatically and, quite honestly, to the point where you're not even exposing the failure to your customer base. And that's pretty important. So the order in which I design would be security first, plan for failure as a second, and then look at performance. Understanding the balance between performance and cost savings is very, very important. I mean, you can get down to the penny on Amazon. An example of that is storage. I think it's less than 7 cents a gig a month for storage. 7 cents a gig. Yeah, that would be a month. It's ridiculously low. So you don't worry about, hey, am I taking up too much disk space? Or, hey, do I need to add another CPU? Because to add it usually is not that monetarily confining. You just do it. The challenges that you run into are when you're used to running at, a run rate of $100 a month for your server, and all of a sudden it goes up to 400, and you realize, maybe I coded something wrong, or maybe we've got a looping problem or something else in that realm. So watching your money is pretty important here. So how does this all work? So the physical layout of Amazon is done with regions. At the highest level is regions and availability zones. A region is a collection of availability zones. It's the largest container, physical container of their infrastructure. And when I say infrastructure, I'll show you some examples, but as we go forward, but you're looking at roughly hundreds of thousands of blades. Not to mention cores, but blades in and of themselves, distributed globally. So availability zones, the concept I wanted to give you here was that an availability zone may be in a single region, but they are physically segmented areas of a data center. In other words, if I'm in the Oregon region and I'm on availability zone US West 2A, and I want to put another host on US West 2B, those two hosts are physically separated. They're on completely different infrastructures for network, cooling, electricity, everything. So when we're looking at fault tolerance and DRP, you're usually good enough to just be able to DRP between availability zones within a given region. That said, most deployments really try to do multi-region fault tolerance where possible. Now, this really wasn't terribly possible up until about 1.5 years, 2 years ago on Amazon because their networking didn't allow you to really cross over regions. But there are ways around that these days, particularly with services that they're offering as well. So at the time of this writing, there were 16 regions, 43 availability zones, and new ones planned all the time. The only glaring missing region, I think, is the Middle East and Africa. But as you can see, there's a blue circle over there in the Middle East that's going to come online, and they're pretty sure that that's going to be able to service most of the ME for a while. I think that one actually came up online last November, if I'm not mistaken. So what is a data center? My friend James Hamilton over at Amazon is the one that designed, his team designed the Perdix, which is these portable containers of blades that you basically can truck around on the back side of semis bring them into a facility, plug in network and cooling and electricity, and you're done. They can move these pretty easily when you're considering the whole thing. At the time in 2012, so they had 500,000 blades or so deployed worldwide. I'm sure that has almost doubled, if not by now. Will be soon. It's all important to know because you want to, as I mentioned, security and fault tolerance are probably your biggest things that that your company is going to be concerned about when deploying anything in the cloud. You can go down as low as layer 2 for each availability zone to ensure physical redundancy and resilience. Most of the architectures are going to be pretty secure-focused, redundancy and cost, but most of them will be security first. Automation and network best practices will leverage the physical model. So in other words, when we start looking at deploying Service Desk or deploying ITSM as a whole, you're not going to first start out by saying, what size machine do I need? You're going to start out by saying, what is the network going to look like for this? Because you want to ensure things are locked down from the very beginning of your design. Any questions? I've kind of flown through a lot on Amazon. I'm not sure if everybody's up on Amazon or not. Cool. So security. What do I need to ask myself about security as it pertains to ITSM? Or, I mean, quite honestly, most of these questions can pertain to any product that you're putting out in the cloud. Data encryption needs. Do your governance and requirements require data encryption at rest? If so, that costs a little bit more. Not a lot, but again, pennies. Do you need to encrypt data in flight? Does that mean that you need to ensure that HTTPS is open across the entire network? Or do you just lock it down and run HTTPS between your endpoints or your CIDR or your particular subnet and Amazon? Patching requirements. Is this something that you want to turn on automatically for the operating system? Specifically with RDS, Relational Database Service. Amazon takes care of patching the engines if you're going to use RDS as your backend for the database. If you prefer a little bit more control, you can certainly deploy, Microsoft SQL or Oracle on your own hosts within Amazon or at your own site and connect to those. Many of the applications that get deployed can leverage scripts. I use Chef. Puppet's been used. I used Puppet in another product that I had a while back. So any of these can be used to automate the patching and the deployment and the configuration of the software itself. When it comes to automation, one of the things that you want to consider is how easy will it be to stand up a new host? For example, I'll use the primary, secondary on Service Desk. The same could probably be said, and is definitely said, with PAM orchestrators. If you want to scale out and you want to add a secondary automatically, you want to know without question what network it's going to be going into, perhaps understand what version of Service Desk you're going to deploy to it. You can build these so that when you launch a host, it pulls the latest version of the software and have all the patches automatically deployed, and write a script that goes and updates the appropriate tables in the MDB so that it's going to be available to the Service Desk primary or your advanced failover design. I forgot. BAA design. Key management is also very important. When it comes to security, you have a root account on Amazon that is basically God, but it is strongly and consistently recommended that you always use MFA. Multi-factor authentication is something that I've always required for any of our users, any of my users on the CA Amazon accounts that I managed, and it's something that I recommend strongly, that if you go and use any public resource, that you're using the strongest possible authentication and authorization methods available. So step one, automate everything if you can. Codebase is awesome. I mean, it allows you to sit down and reproduce and test and fail and then test again and redesign very quickly. You're basically just sitting there with a code change. You're sitting there waiting for the host to come up, which generally takes about 5 minutes. It's a lot faster than ordering a Dell, putting the blade in the rack, making sure you've got it addressed, making sure that it's got everything associated. I mean, it has been one of the crux, it's the crux of the speed at which business is running today. So everything that you do should be code-enabled as much as possible. Day one probably won't be. You just want to see if you can get Service Desk running or ITSM running on Amazon. Cool. But the next thing after that is going to be, well, now that it's running, are we happy with it? Can we just leave it? And the minute you fall into that crevice, that's when problems occur, because an example that comes off the top of my head, Foursquare. Back in 2011, 2012, Amazon had a fire in U.S. East, Virginia, and took out a bunch of resources. Foursquare was one of those resources, and they complained very publicly about Amazon's inability to fail over and have fault tolerance. And it wasn't 24 hours later Amazon shot back and said, look, you guys designed nothing. You basically launched your service on one server, and that's it. So there's always a price to pay. The moral of the story here is make sure you're designing for failure, always, always. Code helps you do that. It's all version controlled. You can go in and check every version, everything that can be deployed. You can literally go in and use Code Deploy and CloudFormation and check in your CloudFormation code into GitHub. Have it looked at by other people, communicate about what you want to do and what you expect it to do, and then have them come back and say, here's some suggestions or fixes or what have you. Very open, very communicative, collaborative, that's what I was looking for. And it allows you to define, secure, and manage your environment by just doing code. You don't have to really worry too much about it being consistent. The nice thing there also is that whether I deploy it or whether Mike deploys it or Bob or whoever, it's always the same. It's always going to be exactly the same. So your QA guy that's in charge of QA in your environment is going to end up deploying the exact same structure that you deploy in production, and temporarily. So if they're done QAing it, they turn it off. You're not making, you're saving money there. Code also enables you this idea of blue-green deployments. One of the nice things about Amazon is that its R53 service, the Route 53 service, allows you to do blue-green. So I can deploy a fully production system, have it running, have thousands of people on it, and start a second system or a second environment and easily migrate people from one to the other just by simple routing. So if you're doing a service, something similar to Service Desk, and you've made changes to, let's see, what's a typical change? So not schema, but let's say you change the web interface or something. You can deploy that on a completely different environment and gently migrate people over. I want 10% of my traffic to go to this new environment. Now I want 20, now I want 50. Or you can do red-black and just say, okay, at midnight I'm switching the DNS and they all go to this new system, that new environment. Rollbacks are just as easy. So again, these are some of the advantages to going down a Amazon Cloud solution. And finally, for those of you who are on VMware today, There's been a direct migration of VMware available since, I want to say 2013 or 2014, I did the beta for it. And that is really sweet because they'll literally lift and shift your VMware images over to Amazon. And in fact, that is something that I use on a quarterly basis for our internal demo systems. Complete lifecycle management of code, yeah, we've covered that, and cost savings are always a focus for this type of scenario. With Amazon, your interface is the command line interface. If you're on a host and you want to run, let's say you're on a host and you want to find out that host's IP address on the public network or on the private network or whatnot, there's a CLI that you always deploy that gives you all of those pieces of information and interacts with the Amazon API. Everything in Amazon is written API first. I should have mentioned that a lot earlier. Everything. So if you're looking at, the Amazon list of services and whatnot, every one of these has a full-blown REST API. Every one of them expose their API to you for consumption, whether that's by your hosts and your environment or whether that's just by you as a programmer. Lots of languages are supported. I'm not going to go and promote too much here. We look at performance. Compute, storage, and networking are all configurable. You pay for performance. There's no two ways around it. So I usually like to start out on the T2 type of instances. And a T2 is a type of instance. They model their instances, their EC2 instances, their hosts, if you will, based on small, medium, large, micro, et cetera. And then they give them categories of memory, memory heavy, CPU heavy. A lot of it depends on the type of load you're going to be using. And it's very important for you to understand the type of load that the products that you're deploying are going to represent. For Service Desk and its toolset, generally a memory intensive or a general model works very well. I've had really good success with the T-Series, and they are extremely cheap because you're only paying for the minutes that you use. If it's sitting there idle, you're actually gaining, you're banking time. And then if you have a spike, you use that bank first. So it's much more cost effective to be using T2 type instances or T3 type instances than it would be the M1 or the M5s or M4s or any of these others. So I mentioned this earlier, how are you going to be using this? How do you anticipate, what do you anticipate, and where do you anticipate your solution being consumed? Some ideas for how to determine that, excuse me. I like bot logging for Service Desk. You run it for 10 minutes, see what you get for a line count, and that gives you a number of transaction messages the messages that have gone back and forth. Generally speaking, as I mentioned earlier, a T2 large is really good for a Service Desk primary for an average deployment that's supporting 500 to 1,000 users and maybe 100 tickets a day. It runs really well. I don't see too much lag time on those. I honestly have not had a significant need to scale out on Amazon. It's actually more cost effective in my research to scale up. In other words, if I am not getting the performance I want out of a T2 large, I will scale up to a T2 2 extra large or an extra large. And in doing that, again, I'm banking time and it's not costing me anything, or it's actually allowing me to bank time for the money that I'm spending. And then when I hit that spike, that's immediately available to me. So I kind of like those. I kind of have been using the T2s quite a bit. You're able to scale up by changing instance type. So this is pretty important. Everybody thinks scaling is always let's add a box, let's add a box, let's add CPU, or let's add a box with a CPU, a set of memory, and a set of storage. You do not need to do that on Amazon. You can simply go in and say, at any particular time, you can blue-green in. And again, blue-greening is that I can go and swap in slowly or fastly a new type. I can scale up from a T2 large to a T2 extra large by simply going in and stopping the instance for the 5 minutes, telling it to relaunch or restart with a different type, EC2 type, and you'll have scaled up quite nicely. It's not as smooth as adding a box, but it is a lot easier for those of you who are starting out on Amazon, and it's usually, again, for the amount that I've had to see service management scale in a drastic, dire fashion, it's certainly it's acceptable to do it that way than to scale out. If you have to scale out, the only thing you have to do there for adding boxes is all of the scripting. So that's pretty important. I missed a question in the queue. Hang on. I don't see the queue, to be honest with you guys. So if there's a question, please interrupt me.
Hey, Brian, there's a couple questions out here. I'm not sure if you hit that in your discussion or not. The first one says, have you used RDS for service management? Since service management requires, requires sysadmin in SQL.
Yeah, so very good question. Have you built an MDB on RDS? I have built an MDB on RDS, but as you mentioned, it required me going through and finding all the grant alls. I mean, you're not going to be able to use the MDB build that comes with the product. For that reason, I generally have steered clear of RDS. RDS is extremely expensive for medium-sized deployments. And in all honesty, I have not had anyone come to me and say, Brian, I want to deploy ITSM for 20,000 users, and it needs to be able to support 1,000 tickets a minute. And so I've usually deployed the database on a self-owned SQL Server or a self-owned Oracle. But I do have a snapshot of an MDB on RDS for anyone that would be interested. I want to say it's from 17.0, though. I have not updated it recently. Does that answer the question?
I think that does. There's a second question here from the same requester. To add SDM app or secondaries dynamically, I presume you will have to have those pre-installed and just use that AMI to deploy to the, I'm having problems with, to the size of the EC2 you're interested in.
That is one way. That is kind of a harder way. You don't have to have everything. For example, the AMIs, when we're talking the templates, one of the nice things about Amazon, when you go to build your network, you can dictate a lot. You can even dictate in your private network especially what IP addresses you're going to be using, how you're going to resolve DNS, what order what order your name resolution is going to take, all of that. So you can, if you wanted to, you can pre-configure for 5 or 6 secondaries on your primary. I'll just use primary secondary because it's in the top of my head at the moment. You can pre-configure all of those in the database and just not bring them online. You can, and because you will know what their IP addresses will be, you can dictate that when you launch the box. The AMI will dictate that. Does that make sense? So again, that's why I wanted a two-way conversation, because I know the questions can get kind of deep and pretty techy. But yeah,
that's all the questions in the queue for now, Brian. Thanks.
Okay, sounds good. So programmatically through the consoles, yeah, we did that. Okay, availability, DRP. I touched briefly on DRP. I have never had I've never had a customer come to us and ask me, Brian, can we DRP across regions? It is possible, but to do a DRP between, the U.S. and South America, okay, but the first question Amazon would ask me when I went to them with that question, they're like, why? Because our availability zones are physically segmented. They're far enough away from each other within the region to be properly isolated in most cases. They won't disclose specific locations without DNR. What is it? Not DNR. Basically the privacy document that they've got. But if you had questions on how are they redundant and anything to do with their redundancy, they have teams that will address that for you so that you're happy enough to know that you can be fully fault tolerant within the same region, but just making sure that your load is divided between two private subnets on two different availability zones. And in many cases, you won't have a choice but to be properly balanced, because you can only have one of for each virtual private cloud that you build, or each virtual network you build, you can only have one subnet per availability zone anyway. So you're going to, in that respect, if you're balancing out a bunch of secondaries or a bunch of orchestrators, you do that across that, both private subnets, and you'll be DRP'd. Higher level of utility segmentation. Yeah, so in different regions is okay for dev prod and whatnot. It makes it a little bit more of a challenge when you want to move things around. Takes a little more time, because you literally, when you're in different regions, you literally have to move that entire set of data out of the region and into a new region. If you're just going between availability zones, that tends to be much, much faster. And then my favorite topic, automation. So when I first started with Amazon in building solutions, I treated it in the worst way possible. I treated it exactly like VMware. I was very excited that I could post stand up a service desk or whatever out on the public internet and have people immediately access it. I opened up all the ports, everybody had access to my 2100 or to 2100 and 8080 and port 80 from anywhere in the world, and wow, that was cool. It took about a month before I realized I had been hacked. And the way I finally found that out was because the bill went up, and there was nobody on this box, and CPU was getting spiked constantly. So needless to say, learned a lesson there. That was when I started looking at how do we lock these things down and automate their deployment, so that I can just say, look, I've lived through this. I don't want, Darren Archangel to go through this again, or Alan to do this again. Why do they have to live through this again? Why don't I just automate the deployment so that it's, it's secured, so that it's reproducible, so it's simple to do? Back then, they didn't really have a way of doing that. We did that with Chef, and we did that with Puppet. We did that with batch scripts. It was really, really messy. About 3 years ago now, maybe 4, Amazon came out with a service called CloudFormation, where you could describe your deployment, network, hosts, routing, everything in JSON format as code, if you will, in a template. It automatically deployed any of those resources in the appropriate order. You didn't have to put it in and say, here, build the network first, and then build these the hosts and second, and then build the routing third. It did it all automatically. It was the sweetest thing ever. And it supports multi-region deployments via CloudFormation stacks now, which is one of the tools that I use if we needed to go and do multi-region deployments. Multiple availability zones, obviously, we talked about on the last slide. Those are pretty straightforward. So up front, it's something that most people will not want to spend time with. They are so excited, or they're so into just making something work and showing value for going to the cloud. but really it is worth your time to understand how to automate and to do some level of automation up front. There is rarely a deployment that I will do where it does not start with a CloudFormation template and a network template. It makes no sense to just stand up a host and put Service Desk on it and say, here it is, because the minute you run into a problem, it's going to die and it's not going to look good for you or Amazon or anybody else. So think automation up front, security, just beating that dead horse here. So we also have a lot of governance coming onto the scene, right? We've got GDPR that just hit. A lot of these, like the one that was really big was, where does your data sit? And until Amazon had a bunker in Germany and a bunker in the UK, or 2 or 3, I guess now, and the other places, Australia, New Zealand, is very adamant about keeping data behind their country boundaries and borders. It was really hard. We had to do hybrid cloud solutions. But now data management can sit on any of those bunkers because they've met the needs for that country's region. In this case, I had put an MDB in Germany, the Frankfurt region. You provision VPC periods, so that Frankfurt is the hub. You basically make a hub and spoke, and the VPC in other regions are spokes for that best performance perspective. So there's hub and spoke formats that you can build from a networking perspective, and that's usually how you're going to be deploying, but there's other methods of networking as well that work pretty good for different applications. Hub and spoke has worked pretty well for ITSM, so I would recommend sticking with that going forward. Amazon, as I mentioned, has their certifications, and those are available through Amazon support. So I'm going to stop here. I'm going to ensure that everybody has access to the presentation, because as I go forward, this was actually a lab. And when we went through it, we actually we built and deployed CloudFormation stacks using templates that I had built for the lab specifically. There was a packet, and again, I can make this will all be available to everyone. And you can go and try building out your own ITSM solution if you have an Amazon account. Let's see, what else can I give you? I'll leave that's actually important. For those of you that want a copy of my templates or a template example, this screen I've opened up an S3 bucket where I put the lab CloudFormation template out there. And I go through in the lab what we do to build a template, the different sections of it, and we go into a lot of the tech of the deployment, looking at the cost. So what we deploy in the lab is a full-blown ITASM solution, and it costs us basically, for the base level, $89 a month to run that service. And that was per deployment. So you get a full environment, $90. Now, mind you, people will step back and say, well, I can buy a server for $2,400 and do the same thing. Yes, you can, but you're also paying for all of the physical infrastructure for it, all the support infrastructure for it. So ultimately, it does show to a CFO, it shows as much cheaper to be hosting or running on Amazon. What else? Anybody have thoughts? Did I miss anything in the questions? Yeah.
Brian, did you get the chef and puppet question?
I did not.
Okay.
When I'm presenting, I don't get to see all the cool chat windows and stuff. But here,
okay. So the question is, will you get into automatic patching of service management using these or other tools, chef and puppet?
It's actually pretty straightforward now that service management has standardized its patching methodologies. Before, when I had to use apply PTF, you could have just killed me. But now, let me see if I've got it here. I can show you. actually in a template where you would do that. There, right here. So up here, this is an example with running a batch file at the time of launch. But if you include the patch or a batch file that you would have on your AMI that would run any batch, patch that's passed in, you would be able to automatically at launch time patch the host up straight away. Again, you're not going to go back and patch existing hosts. That's not, we want to treat these things like cattle. If you're going through and updating your system, and again, it depends on the patch, it depends on what you have to update, et cetera, or how it gets deployed, but normally you can go and launch these things as part of your launch of a new host. And you just bring up the new one, red black it, or blue green it in, and get rid of the old stuff. Far faster, far easier, and you can test it offline to make sure everything's happy and hunky-dory before you go and kill your old server or your old services. But I generally, so patching I would add the executable in, back up there. I would add the executable as part of a launch script in user data for my template. And again, that's code. So anytime I change this, I check it into GitHub or into code deploy, and we're able to let everybody else use the exact same thing.
So Brian, this is Bob Schubert. Do you have codified the installation of the different service management tools as well?
Didn't need to. So that's the template. So I do it once, and that's it. And then I patch. So I'm not recodifying everything. For example, if the root of your question is, how can I get this stuff? I would just share out, or I would ask CA, as long as you're, paying for the software and everything, as long as everybody's legal. Normally the process would be, give me your Amazon account number and I'll share out the AMI. And that would show up in your private list of AMIs and you launch that. Does that make sense?
It does, yeah.
Okay. Why make you do it if I've already done it, right?
Right, that's great, yeah.
That's the whole purpose. That's a big payout on this. And the community would be huge on this. I mean, if you guys got together and started looking at how to build some of this stuff, or leveraging what has already been done, I think that'd be awesome. What else? I can just page through this here, see if there's any interesting, fun stuff. So let's see, mappings, pre-baked AMI, there we go. So on your pre-baked AMI, and that's what they're called. So if you've got a template, the equivalent of a VMware template in Amazon is an Amazon machine image or an AMI or AMI. You could have a root or base AMIs, which are just the raw operating system, which I used to use. I don't really need to bother with that anymore because of the amount of templating and the amount of automation I've built. But ultimately, the idea is to be able to pull any of these latest and greatest base operating system templates and have Chef or Puppet or scripts pull the software from CA support site, automatically install it, right, with either a silent install or whatnot, and then automatically patch it. That's the nirvana you get to. Given the age of some of the software out there, and given some of the limitations of the architecture, you can't always do that. I found it was, doable with service management, but it was extremely painful. It was far easier to just go and manually build your AMI, a pre-baked AMI, and then, especially since we changed our release schedules to, full year, 17.0 and whatever's coming up and whatnot, to full year increments, because ultimately, the database you want to keep. So you would do a manual migration of that AMI, cut a new AMI, and now that's the one that you change in your CloudFormation stack code to launch for the next time, or to blue-green it in. Again, you're never replacing, I guess. How can I put it? You're going to have your environment, your production environment, but you can onesie-twosie in new servers, or you can completely blue-green in a very brand new production environment, both pointing to the database. At cutover, you would point the new one to the old database, and you're up and running. It's just a DNS change. So that ultimately is how I change things over. Now, mind you, I am not running ever under a production load, guys. So a lot of stuff that I do is, ITASM, it's demos, it's, making sure that this stuff is easily deployable and that we have models on how we can address this, for our services team and for our MSPs that want to look at doing things on Amazon in a more automated fashion. What else? So these were some challenges. One of these, how do I patch the OS for these environments? So one of the challenges was how do I update and patch? And as I mentioned, we modified the CloudFormation template to include a different admin. You don't have to visit each service or server manually. You just blue-green them in. And if they fail, you can go back because it's all version controlled. So how would you, just to give you an idea as to what the code looks like, I'm giving you code snippets, but again, I'll throw this all up on, Chris, we can post the PowerPoint, right, for everybody?
Yep, we can. Yep,
right on. So some examples, this is actually a really good slide. Down here in the lower right, I've got, where's my pointer? I need a pointer. There we go. Down here, this is really important. So whenever I want data about my system, let me get rid of this. I don't need to annotate anymore. I want to get rid of that box. Sorry about that. Anytime I want data about the host specifically, or if the host needs to be aware of where it sits or what it's doing, or in this case, I wanted some IP addresses, it's all API enabled. I mean, I can just simply use curl and ask it, what's your public IP address? Because the address you'll have if you use ipconfig will be the internal, the local IP for v4 address or 6. They're both supported. So this is an example of just a very basic batch file that I use to update the host file, so that every service that's deployed will always know exactly what its IP address and what its resolution should be. That's actually one of the challenges that we ran into very early on. When you stand up Amazon and Windows Server on Amazon and you install our services, if you're not modifying the host file appropriately, the name resolution will not work outside of Amazon, outside of that actual host, to be honest with you. It won't go anywhere because it's just going to address it to the local IP address. What other great cool things can I talk about here? Let's see. So this is what it looks like when you get output from your stack. One of the challenges in the lab was to change the URLs from an IP address and port number to actual FQDNs. And we walked through that in the lab. So we're a bit over at the moment. If you have any questions or thoughts, or if you guys are looking at any of this, of doing any of the Amazon stuff, by all means feel free to give CA a call, drop me an email, what have you, and I would be happy to do my best to help you all out.
Thanks, Brian. This has been a great session, really good information. I think the slides are going to be most useful to some folks as well, so thanks for that offer. And if anyone has interest in watching this again or getting others to watch it, this will be posted on the community as one of the webcast recordings. So please take advantage of that, pass it out to others, and please stay tuned for some additional community webcasts we'll be doing focused on non-IT uses of CA service management, and that'll be coming up over the next couple months here. We'll be doing a series on that. So we appreciate your time today. Brian, we appreciate your time and all the information you conveyed, and hope everybody got a lot out of it. And that'll end today's webcast. Thanks, everybody.
Thanks, guys. Have a good one.